Okay. Shh. So if we want to sketch the graph, we have the first half is 3, 1. We have 3, 1 here, and we have 6, 4. Okay, 6, 4. And it is this part of the graph. I can have like this. And we have square root. Okay, we have square root. So y equals to 3 square root x. So this point is 6, 4. And this point is 3, 1. So you must have 1, 3 on the other graph as endpoint as well. So I have 1, 3 here. And I have 4, 6 as well. So I have 4, 6 here. Because it's changed the x and y values. Okay, so your endpoints will still be endpoints, but you will swap the values. Okay, so 1, 3, 3, 1. They are like a pair. So they will look like this. Okay, so that's 4, 6, and that's 3, 1, 3. Okay, that's the graph of this. Okay, I'm going to do the next one. The next one will be quite similar to this. Is there any harder ones we can do? Okay, I give you a lot of practice, but I'll try this one first. Okay, first of all, I want to have f is x minus 1 squared plus 4. So the domain of f is 3 to 6. Okay, so I'll think about what's the range of f. So if I can sketch this graph will be 1, 4 as the turning point. 1, 4 as the turning point. So somewhere here. So the graph looks like this. Okay, something like that. And my values take from 3 to 6. My values from 3 to 6. So it's after the turning point. It's to the right side of the turning point. So it's an increasing graph. Let's think about F3. So F3 equals to 2 times 4, 4 plus 4 is 8. So y is equals to 3. You will have 8, which is here. And the next one, y equals to 6. 6 minus 1 is 5. 5 times 5 is 25. 25 plus 4 is 29. So you have 629, which is here. So it's a quite thin graph. So something like that. So you will have 3 and 8 and 6 and 29, like this. Okay, so the range is 8 to 29. Okay, the range is 8 to 29. Number 3, I will swap x and y positions. So x will equals to y minus 1 squared plus 4. Y minus 1 squared equals to x minus 4. Okay, what y minus 1 equals to, everyone? What y minus 1 equals to? Plus minus square root x minus 4. Good. So y will equals to 1 plus or minus square root x minus 4. Okay, so still this is question mark. I don't know to take positive or to take negative. Okay, but I'll keep going. So talk about what is the domain of f inverse, which is the range for f, which is 8 to 29. Number 5, what's the range for f inverse? Actually, this should be number 4, then number 5, that's number 6. So range for inverse is domain of f, which is 3 to 6. Okay, which is 3 to 6. Okay, so it's all positive values. So 1 plus something and 1 subtract something I need a value, I need a range which is in between 3 and 6. Can I have one subtract a positive value? I cannot subtract. I can only add things to 1 to make it to 3 to 6. I cannot subtract anything down now. So I will have y equals to 1 plus square root x minus 4. So if write in function, I'm not going to write first, I'll sketch it first. I'll have 3, 8. Then I will have 8, 3. Okay. 8, 3 is here. I'll have 6, 29. I have 29 and 6. So 29 is here. And you have 6, which is here. So I have 2 points like that. And that's a square root function, so it will look like this. I will have 8 and 3 and 29 and 6. Like this. So write in function notation. If write in function notation, I have f inverse 8 to 29 mapping to r, comma, f inverse x equals to 1 plus square root x minus 4. Okay. Okay, I want to quickly talk about one thing. I'm not going to give you an example, but I'll quickly talk about this. When you're trying to find the intersection for original graph and inverse graph, how you should be able to do that? Okay, you have fx function. Now let's say, for example, you have fx function and you have f inverse function. How you find the intersections between that? What's the intersection? For example, those two graphs we do without intersections. But say if we find two graphs has intersections, how you should be able to find intersections between the f graph and f inverse graph? Simultaneously solve them? That's not a good method. Simultaneously solve that is not a good method, because if you do VCAP paper, you will find in 1 year, the paper, if you solve those two questions simultaneously, you will see there's no solutions. Okay, I tried to do this question, and if you solve simultaneously, there will be no solution, because the calculator is not good enough to calculate that out for you. Okay, it's too complex. So tell me, what character is the intersection point has? Y equals to x. Exactly, y equals to x. If those values have exactly the same x value and y value, they will intersect for sure. Because if you 3 and 3, you swap x and y, you still have 3 and 3. So this point must be both on the original graph and the intersection, the inverse graph. So you are not going to solve those two simultaneously. You are going to solve fx and y equals to x simultaneously. Okay, so it's the intersection between 3 lines, fx, f inverse x, and y equals to x. It's actually the intersections between 3 lines, not only 2 lines. Okay, so if y can be equals to x, then this point must be point of intersection. So if you can solve simultaneously by y equals to x and y equals to fx, you solve out the x value, and y value will be exactly the same. Y will be that value, and that point will be the intersection point. Okay, you are not going to solve that simultaneously. Okay, you are not doing that. If you do that, waste of time, and some of the time your calculator cannot find value for you. Okay, that's the thing I want to talk about for inverse. Basically, I cover most of the things inverse should have. You have some exercise from practice here. I have 1 page, 2 page, and 3 page, 4 page. Okay, I have 4 page here. Okay, take your time. Okay, I'm not supposed you can finish in 1 day, but take your time. Just needs to finish that finally before I finish this booklet. Okay, you gradually do 2 questions a day. Here.